In this video, we'll be taking a look at the timers which are used in PIC microcontroller and the features which are provided. So, timer is basically required to keep a track of time. So, in digital systems, the time is represented by a count in the timer, and if the timer counts some events, you call it as a counter. So if it counts clock pulses, then you call it as a timer, and if it counts some events, you call it as a counter. Now, those events are the ones which take place outside the microcontroller. So this is why we require a timer. So if you take a look at the block diagram, then you can see first thing is the source signal can either be a synchronous clock, as I said, or it could be an event which is connected to the timer X clock pin. Now X will be equal to 0, 1, 2 depending upon how many timers are there. And the current value is stored in a register which is called as a timer or a counter value register. So this is a block diagram. So this one, so this is a timer, and the input to the timer can either be from the oscillator, that is clock, or it can be some external uh, pulses which can be given to the timer. Now the selection whether you want to give the oscillator frequency to the timer or you want to count external clock pulses, it can be done using uh, a clock source select bit. So once the source is selected, the waveforms goes through a block which is called the prescaler. What this block does is it will divide the frequency by an integer. So you can slow down the rate at which the timer works. Then if you see the next block, it is a block wherein you can enable the timer or you can disable it. So if you enable the timer, in that case the clock input will be given to the timer, else the timer will be disabled. So once you start the timer, when the timer is enabled and it is loaded by some count and you start the timer, then it will start counting the count in either upward direction or downward direction depending upon whether it is an up timer or a down timer. Up timer means if you load the timer by a value equal to 0, 0, 0, 0, then it will go to the next state which is 0, 0, 0, 1. It will start counting from that value, and when it reaches FFFF, that is if you consider it as a 16-bit timer, it will reach to a value FFFF all ones. The next state will be equal to 0, 0, 0, 0. So when it rolls from all ones to all zeros, we say that the timer has overflowed. So whenever the timer overflows, if interrupt is enabled, the corresponding interrupt is generated. So this is a basic block diagram of a timer. Then we'll take a look at what is a prescaler and a postscaler. We have already discussed prescaler. Prescaler is a is a way in which you can decrease the frequency at which the timer works. So if you want the timer to work slowly, you can increase the value of prescaler. So if the source signal is having a frequency equal to say 10 megahertz, and if you have a prescaler of 2, then this timer will work at a frequency 10 by 2, 10 megahertz divided by 2, that is 5 megahertz. Now when the timer overflows, a timer overflow flag is set. Okay, and then there is a concept of post scaler. So this flag will be set when every time the timer overflows. So if the post scaler is 2, then when the timer overflows twice, in that case the timer overflow flag will be set. So this is what is a post scaler. So there are timers in which you have post scalar feature, and Some timers do not have that feature. So this is pre-scaler and post. Now, as far as PIC 18 microcontroller is concerned, the controller that we'll be taking a look at is PIC18F458. It has 4 timers, and the names of the timers are timer 0, timer 1, timer 2, and timer 3. Now, these timers can either be 8-bit or 16-bit. So, some of them are configurable. So, either you can make it to work as 8-bit timers, or you can make it to work as a 16-bit timer. So if you see, there are 4 timers: timer 0, timer 1, timer 2, and timer 3. So out of which timer 0 is a 8/16-bit timer. That means you can configure timer 0 as a 8-bit timer, or you can configure it as a 16-bit timer. Timer 1 and timer 3 are both are 16-bit timers, and timer 2 is a 8-bit timer. Now, for a timer, there are special function registers associated with timers. So, why do you require SFRs or registers? So, for controlling the operation of timer. So, for timer 0, you have timer. It should have been timer 0 control register, T0 con register, and INT con register. So, to these timer 0 control register will have bits to control the operation of timer 0. So what are the operations that can be controlled? The starting of timer, stopping of timer, etc. Setting up of a pre-scaler. If it has a post-scaler, then setting up of that bit, etc. So you need those features, that those are incorporated in the control register. And you have one more register which is used for the overflow flag. So for timer 0 overflow flag, the uh, control the special function register is int con. So it will have a bit which will be timer 0 overflow flag. So similarly, you will have different registers associated with timers. This timer 3, it should be T3 con. Okay, so these are the SFRs associated with timer. Thank you.